What's up, gamers? I'm Amanda Cao here with another CS14 SI video. Today, we are going to go over hash tables, chaining, linear probing, and quadratic probing. Now, the reason why we love hash tables so much is because it gives us an O of 1, insert, search, and delete. Oh my! And how that works is that we take a key, put it through a magical black box we call a hash function, and that hash function will assign that key to a unique index that will be used to access that key and that key alone. However, the downside is that you can only insert hashable objects. Now, what does hashable mean? Hashable means it's gotta be unique, essentially. So you can't exactly have a hash table full of the thousands of John Smiths in the population. However, if you want to say, I don't know, hash John Smith's credit card number, expiration date, and the three digits on the back, that's a little bit more doable. Another thing we have to consider when implementing hash tables is handling collisions. Ideally, we'd like our hash functions to give us unique indices that don't collide with each other, but sometimes that happens. As you can see in this image, John Smith and Sandra D both got the same index from the hash function. So how do we handle that? One way to handle collisions is a method called chaining. It's pretty simple. All you have to do is whenever you hit a collision, you simply create a list at that index and just append the key to that list. Another method is called linear probing. When we hit a collision, instead of creating a list, we simply insert the item at the next available index. So in this example, when Sandra D collides with John Smith, we simply insert Sandra into the next index. And then when we want to insert Ted Baker and it collides with Sandra D, we also insert him in the next available index. Let's look at another example. So say we have this hash table and delete the items so that it looks like this. How do we find 88? Say the hash function for this hash table is whatever the input is mod 10. So to find 88, we would initially look at index 8. However, we can't find anything at 8. So does that mean 88 simply isn't in the hash table? We know that isn't true because 88 is right here. So what does that mean? What happened was when we were inserting 88 into the hash table, index 8 was already occupied with a key at the time. So using linear probing, we simply went down to 9, 0, 1, and then eventually 2, where we found an empty cell to insert 88 in. So in order to find 88 in the hash table, we simply have to retrace our steps. Whenever we delete an item from a hash table, we mark them as empty after removal. So whenever we're trying to search for an item and we hit an empty cell, if it's empty after removal, that means there was already an item there. So then we can simply keep on searching down and circling back around the hash table until we eventually either hit the item we are looking for or an empty since start. Quadratic probing is handled exactly the same way as linear probing, except quadratic probing has a different function we use whenever we hit a collision. Let's take a look at this example. First, we insert 15, 11, and 27 with no issues, and then we try to insert 8 and collide with 15. Using our collision function over here, we take our original hash index, which is 1, the number of collisions we had, which is also 1, and input into the function like so. 1 plus 1 plus 1 squared, mod 7, and we get 3. and 3 is empty, so we simply insert 8 into the hash table. Then we'll try insert 48 and get a collision with 27. Pretend that 42 is 48. Using our collision function once again, our hash function gave us an index of 6, and we've collided once. So using our collision function, we get 6 plus 1 squared mod 7, which equals 1. Now we go to index 1, but it's already being occupied by 15, so we have to go through the collision function once again. Now the number of collisions is 2, so we have to input 6 plus 2 squared mod 7 for our collision function and get 5. As you can see, 5 is empty, so we can insert 48 just fine. Lastly, we insert 420 and complete our hash table. Again, quadratic probing is implemented almost exactly the same as linear probing, so you'll have cells marked as either empty from start or empty after removal. And instead of searching for objects cell by cell, you would use the quadratic probing function to look at objects sequentially. Now, one last thing I want to note, even though you know how to handle collisions in hash tables, obviously you would like to avoid collisions in the first place. If collisions get too out of hand, you start getting really long chains like this, or end up probing several times before finding an empty spot. And that kind of takes away the of one time we are looking for. So you need a good hash table so you can avoid collisions altogether. But I'm not going to go over that today. That'll be covered in the next video. And that wraps it up for today's video. Thank you so much for watching. And if you have any questions, feel free to comment down below or come to any of our sessions posted in the description below. This is Amanda Cao, signing off.